Hello, good day. I am Dr. Juan Carlos Rodriguez Sierra. I am a researcher and professor at the La Unidad Profesional Interdisciplinaria de Ingeniería Campus Guanajuato del Instituto Politécnico Nacional in Mexico. This is a multidisciplinary work in collaboration with Dr. Juan de Dios Ortiz Alvarado and Dr. Mario Aguilar Mendez. This one is the corresponding author. Thank you for your interest in this poster. I will present to you through this short video the research work entitled Optical Measurements of Cyanobacteria Biomass Based on LED Discharge by a Paired Emitter Detector Diode. Aquaculture is defined as the cultivation of aquatic organisms with the aim of increasing and optimizing their production through various operations and techniques, including protection from predators. Aquaculture is currently one of the fastest growing food production systems worldwide. Microalgae is an important live food source in several aquaculture systems, usually is required to feed the larvae stages of fishes or aquatic invertebrates.
Eutrophication is the enrichment of nutrients in an aquatic ecosystem. It begins when the water receives new nutrients, such as agricultural or forestry waste. This causes the excessive growth of organic matter, leading to the accelerated growth of algae and other green plants, which cover the surface of the water and prevent sunlight from reaching the lower layers. Therefore, its control and biomass monitoring are crucial for a healthy aquarium. We propose a novel design of a paired emitter detector diode for optical measurements based on LED discharge as a low-cost solution for monitoring the density of microalgae in aquatic systems. Also, his work presents the evaluation of the effects of the operating frequency of the microcontroller and the power supply current of the light-emitting diode, LED, on the sensitivity of optical measurements.
The figure A shows the setup scheme of the PDD configuration. It's composed of two LEDs with the same emission wavelength. Using an LED as detector allows wavelength selectivity and reduces disturbances from external illumination. One LED operated as detector, this is connected to output terminal of the microcontroller. The other LED is used as a light emitter. This LED is connected to a voltage source, and by means of a limiting resistor the supply current is established, and with it the luminous flux emitted by the LED. The sample to be analyzed is placed in the propagation path of the light beam, and light attenuation produced by turbidity and absorbance is detected. Figure B shows the voltage curve of the detector LED. In the initial phase, the terminal that is connected to the detector is configured as output with high logic state. This produces an inverse bias voltage in the LED and induces the charge of the capacitance of the semiconductor junction of the device, which is determined by the magnitudes of bias voltage and incident luminous flux. After the established period for charging, TC, the terminal is configured as input and the photocapacitance is discharged through the impedance of the input terminal and produces a voltage discharge curve similar to a RC circuit. At the beginning of the discharge phase, an internal timer counter of the microcontroller is started, and once the discharge voltage reaches a value lower than the minimum threshold voltage of the logic value high, the timer counter is stopped, and the timer count is recorded. This value is correlated with the intensity of the luminous flux obtained by the detector LED.
The schematic diagram of the implemented system for experimental evaluation of PEDD configuration is shown in this figure. A development board based on the STM32F103C8T6 microcontroller, ST Microelectronics Incorporated, was used. It includes 4 16-bit timer modules. For the evaluation of the PEDD configuration under different operating conditions, 2 measurement tasks were performed. One turbidity estimation was conducted on samples with different turbidity value, obtained from serial dilution of the reference standard of formazine Turb 1000, Sigma Aldrich Incorporated. The LED SFH4550, Vichy Incorporated, was used for emitter and detector of PEDD. The peak emission wavelength of this component is of 860 nanometers and meet ISO 7027. 2. Estimation of biomass concentration of Spirulina platensis microalgae in solution. For this task, the strain CIB83 of Spirulina platensis was obtained from microalgae collection of the Centro de Investigaciones Biológicas del Noroeste, Sibner, Mexico. Figure shows the responsivity of timer count value obtained for turbidity and biomass concentration increment, with current supply for LED emitter of 5 mA, 10 mA, and 15 mA. This produces a proportional increment of light intensity generated by LED emitter of PEDD. It can be observed in both graphs that at low current supply, and therefore low light intensity, the system is more sensitive. However, a high dispersion on timer count readings is obtained because of the low signal-to-noise ratio. The curve obtained with 10 mA of current supply shows an acceptable sensitivity with low dispersion for turbidity and biomass concentration and suggests this as a suitable operating condition for LED emitter. Table shows respectively estimated values for turbidity and biomass concentration with microcontroller operating at the frequency indicated, and the relative error obtained by comparison with the nominal value of turbidity and biomass concentration of the sample. Because of the increased operating frequency, the power consumption of the microcontroller is increment. This value was measured experimentally and reported in table. From the data shown, it is observed that at low frequency of operation the estimated values present a greater deviation from nominal values. An increment of frequency reduces to relative error. However, the increment from 32 MHz to 72 MHz does not produce a significant improvement in accuracy. This indicates the trade-off between accuracy and power consumption that shall be considered for the application of this scheme on battery-powered systems.
The analysis carried out under the operating conditions of the PEDD configuration shows that both the intensity of light emitted by the emitting LED and the operating frequency of the microcontroller determine the performance of a measurement system that applies this configuration. The results indicate that an evaluation must be made of the levels of the mentioned parameters that allow obtaining suitable sensitivity of the system when the intensity of the LED emitter and clock frequency of the microcontroller is modified that allows obtaining a balance between power consumption and accuracy. This prototype is a low-cost solution to monitor the microalgae concentration in aquatic systems. Furthermore, real-time online data acquisition can improve the reaction time of decisions based on microalgae control. The authors acknowledge the financial support of Secretaría de Investigación y Posgrado of Instituto Politécnico Nacional under Project 20240-248. Also, we are thankful to Aquarium for the grant to attend the 2024 International Aquarium Congress.